All right, class. Yesterday you started classwork for page 312. You finished it up this morning. These are your answers. I want you to pause the video, check your answers. When you're done checking your answers, either find a classmate to discuss the ones you both got incorrect and figure out the right way to solve that problem, or ask Mr. Burns or ask Miss Russell to give you a hand. And then I want you to come back, start the video over, and just watch it through the examples of how to solve these multiple step equations. And then you're going to watch it a second time. Then I want you to pause the video and start taking notes like we would in class if I was writing the notes live for you. So first you need to know and become familiar with a couple of different properties. We talked about the addition and subtraction properties of equality. If you add the same thing to both sides, the equation stays equal. The same thing works with multiplication and division. So you have the multiplication both of these properties very similar to the addition and subtraction. Multiplication property of equality, if you multiply, and let me backtrack, when you're writing these, leave some space so then you can write in some examples. The multiplication property of equality means if you multiply both sides by the same thing, it stays equal. So if I have 8 over 4 equals 2. I multiply both sides by 4. That cancels, so I end up with 8 equals 8. And then the division property of equality, same idea. If you divide both sides by the same number, so if I have 8 equals and just give me 1 second. I want to find you the correct example for this one. If I have 8 times 4 equals 32, then I divide by 4. I divide by 4. That cancels, and that leaves me 8 equals 8. So now you can see the example. You're dividing both sides by the same number, so then the solution, both sides come out to be equal. And then you have the multiplicative inverse property. This property, the word inverse, should tell you that you're using the reciprocal or the inverse of the fraction or the whole number. And of course, then you're multiplying. So you're multiplying the inverse. So if I have 5 times 1/5, that comes out to equal 1. So just like with the reciprocal when we multiplied fractions, that you multiplied by the reciprocal to come out to equal 1. The only time it doesn't work, say I have n times 1 over n, that's going to equal 1 as long as, so except and n cannot equal 0. So you can't multiply both sides by 0 and expect to come out with the same thing. So I mean, they both equal 0, but not the same thing. So let's walk through multiple step equations. So this first time through, I want you to just watch it, and then you can take notes the second time through. So just like the single step equations, when you had just the variable on one side, you want to get the variable by itself. So you want to get the term with the variable by itself first. So we're going to multiply by 5. So that way we can cancel out this dividing by 5. And then you have 2n equals 70. Now that you have this, you can get the n by itself by dividing by 2, or the inverse of multiplication on both sides because of the equality property. So then you have 35 equals n. Now we're always going to check the solution because we want to know that we can start the next problem with a nice clear mind, knowing we've got it correct. So I rewrite the original problem, except I'm going to be plugging in my solution for the n. So 14 equals 2 times 35 over 5. So when you're filling these in, now that I don't have variables, I'm going to follow the order of operations. 2 times 35 is 70, so I have 14 equals 70 over 5. Now, that one might be a little tougher to do in your head, so just don't be afraid. Do the work on the side. And you see that 70 divided by 5 equals 14. 14 equals 14. So then now I can move on to the next problem, knowing that I've got this one done correctly. It's all about canceling, doing the inverse operations, and isolating the variable. So your goal for all of them is every time is to isolate the variable. That's your goal. You see how the variable's all by itself. Now it's not just gonna work with multiplication and division problems. It will work if you have addition and subtraction. I have 3n plus 4 equals 29. Now I can already see here that this will come out to a decimal, but I want to get this term by itself first. So I'm going to do the inverse of adding 4 would be subtracting 4 from both sides. You can't just do it from one side. So plus 4 minus 4 equals 0. I have 3n equals 29 minus 4, or 25. So now I have 3 times n equals 25, and I want to divide by 3. This would become 1, so we don't write that, so that will cancel out, ultimately have n by itself. And we divide this side by 3 because we did that over here. Do the same to both sides of the equal sign. And I don't know this one off the top of my head. 25 divided by 3. I know it should be something like 8 point something. 8 times 3 is 24. I get 1. I'm adding decimal 0. Don't leave this as a fraction. Turn it into a decimal each time, unless you have a fraction in your equation. 3 goes into 10, and 3 times, that's 9. And you can see that this will begin to repeat, so you can just use 8.33. That way when you check it, you get closer to your actual answer. So I plug it in. 3 times 8.33 plus 4 equals 29. 3 times 8.33 ideally will come out to 25, but it'll be 24.99, so 25. 994. So I have 24.99 plus 4 equals 29. You add that, you get 28.99 equals 29. And because we had to round this never-ending number, then this is 29 equals 29. So you know that you got the correct answer. Now I want you to solve these 2 problems on your own, using the video, using your notes. Just try them out, make sure you show your work, and check your answer. Then come see Mr. Burns or Miss Russell, and then we'll give you the green light or help you with the problem so you can start the classwork assignment. So I want you to try this one. And this one on your own. If you're not sure what to do, watch the video again. Just make sure you show all of your work.